All right, what we're going to look at today is one variable inequalities. And what you're going to be able to tell pretty quickly here is that equality is kind of a big deal in society. And the fact that equality can sometimes be hard to achieve means that there is inequality in certain situations. So there's a lot of emotion kind of wrapped up in this idea of inequality, whether it's age or income or opportunity, fairness. All these things can be described as unequal, but we have more than one way to describe unequal. And if we look at the four main ones we're going to use in math, we have less than or equal to, greater than or equal to. And here are the symbols that represent each of those things. Now, if we're looking at the real world, we're going to have a lot of inclusive statements. Inclusion means that there's an equal to part. It means the number can be exactly what's stated. So if I were looking at a speed limit, for instance, if the speed limit's posted at 55 and I'm driving 55 miles per hour, then I'm within the speed limit confines. It's inclusive. It includes the number that's printed on the sign. If there's a weight limit or a height limit or an age limit, time limits, these things are usually inclusive limits. So if I have 20 minutes to take a test, I get that 20th minute. It's not less than 20 minutes, I get the full 20 minutes. So when I look at limits in the real world, it's usually inclusive. If I'm looking at exclusion, meaning it has to be less than or greater than, then I can't have two things being equal. It wouldn't be exclusive if two things were equal. So where this comes up in the real world is mostly with games. I play a lot of games where you get a bonus if you're the player who has the least or the most of something, but it has to be unique. If you're tied with somebody else, then you don't really have the most or the least, so you don't get the bonus. Now, here's the reason that we use or don't use exclusion. If I tell you you have to complete more than 5 modules to earn credit for Algebra 1, you're going to remember hearing that 5, so you're going to go out and complete 5 modules. But you haven't met the requirement, so therefore you wouldn't get any credit. A better way for me to say this is, instead of saying more than 5, I should just say you need to complete 6 or more modules to earn credit. Because you're going to remember whatever number I say, that's what you're really trying to remember long term. So it's best in the real world to use the inclusive statement so that the person can just remember the number you said. So let's look at how to solve inequality problems. The reason it's different from equation is there's more than one answer. In an equation, you can say x is 5 or x is negative 10. But if I say annual income is less than 74,000, I can't list all those possibilities out. 1 cent, 2 cent, 3 cents, all the way up to $73,999.99. It's unrealistic to make a list that long. So we have to have a graph to represent all of the possible answers here. So as you can see, I have a number line. In the middle of my number line is 0. Over here I have 74,000. I don't have to go ahead and list increments all the way to 74,000. I'm just going to put the 74,000 there. And then I'm going to put this open circle to say it has to be less than 74,000. It can't be exactly 74,000 because that's not less than 74,000. And I made an arrow going to the left. Now, if we were to look at graphing inequalities, we're going to see that my goal anyway is to get the variable by itself on the left. And I'm going to have to do some of these steps in order to make that happen sometimes. And we're going to notice this one caveat at the bottom. If you multiply or divide by a negative, your inequality gets flipped. We're going to look at why that happens a little bit later on. So if I look at n is less than 2, I make my graph here. And you can see the very first part of this graph is that I had a boundary of 2. In my original statement, I had a 2 here. So it would make sense that I would want to start my graph at 2. Notice, open circle, 2 is not part of the answer. 2 is not less than 2. So I move with an open circle to say it can't be exactly 2. And then you're going to notice that my arrows go into the left. As long as you had the variable by itself on the left here, the inequality symbol points you in the correct direction. So this inequality symbol is pointing left, so my arrow is pointing left. It's a neat little way kind of to remember which way you're supposed to go. Now, of course, that only works if you got n by itself on the left, but I really like this process for knowing which way to draw my arrow. Now we look at, well, what happens if p is on the right side? I was just talking about how you want to have it on the left side. What we're going to do here is we're going to think of a mirror. We're going to think of putting a mirror here and seeing what the reflection looks like. And I did my best here to create the mirror, and here's my reflection. It also kind of looks like a book. You can think of it as folding a page over in a book. So as you fold this page over, the P is close to the binding. It's also close to the binding after you do the reflection. So when you look at what happens when I do that reflection, really you can see that I swapped the two numbers. So instead of the -2 being first and the P being second, now I have the P first and the -2 second. I didn't change any of the signs at all. The -2 is still negative. The P is still P. The only thing that really happened was this inequality in the middle is now facing the other direction. Now we get to our third kind of condition. What if there's a negative in front of my exponent? It's on the left side like it's supposed to be, but I can't accept that negative being there. So we're going to use a math shortcut. We're going to divide both sides by -1 to remove that coefficient. And we did that when it was an equation, and it was great. But I want to show you from the pure math sense what dividing by a negative really is. So it's really a multiple step process where you're using addition or subtraction to move terms around, and then you're going to finish by reflecting the inequality to get the variable back to the left side. So when I look at this problem, -x is greater than or equal to 1, I'm going to add x to both sides to get the x over here, and then I'm going to subtract 1 from both sides so that the number and the variable are on opposite sides. I don't want my constant and my variable on the same side, I want them on opposite sides. Now I've resolved the issue. This x is a positive x, so I've done what I want to do. Unfortunately, it's on the right side of the equation. Well, the right side of the inequality. I want it on the other side. So I'm now going to do the reflection. If we put that mirror up, you could see how it would reflect over. And now I get x is less than or equal to -1. Yay! So here's the shortcut. When I divide by a -1, what I'm really doing, if you look at the difference between what's up here and what's down here, I'm flipping the inequality and I'm changing both of the signs. The -x became a positive x, the inequality flipped, the +1 became a -1. So that's kind of the summary that I'm going to put on this now. Dividing by 1 is changing all the signs and flipping the inequality. Some people refer to it as change, flip, change. Change the signs, flip the inequality. So if we look at that graph, it's not ready to graph because I have a negative in front. But when I do change, flip, change, as shown here, now x is by itself on the left, so I'm able to make a graph of this equation, and that's what it ends up looking like. The solid, it's going to the left, because I look at my arrow, it's pointing left. But this time the dot's filled because 1 is part of the solution. -1 is equal to -1. So I like that. The last thing you're going to see as we go into this unit is sometimes you need to add or subtract things. So to get x by itself here, I have to add 5 to both sides. Once I do that, then I'm going to have to divide by 2 to get x alone. Over here, I do the same 2 steps. I'm subtracting 14 because I want the x by itself. I'm dividing by 3. But on this one, x is on the right side, so I'm then going to have to do a reflection to get it over to the other side. So I actually end up with 3 different steps to do for that problem. And then on the last one, I'm multiplying by 5 to undo this division. That turns it into 35. And then I'm dividing by -1, which is change, flip, change. And we can see what you get for an answer there. Change, flip, change, negative 35. So we don't have to graph them, but I wanted you to see those are all the different things that we're going to do with inequalities. Thank you for watching my presentation.